What are Python's dynamic typing and duck typing?
Python is renowned for its dynamic typing and duck typing, both of which contribute to the language's flexibility, ease of use, and popularity for rapid development. These two concepts are central to Python's design philosophy, which emphasizes readability, simplicity, and developer productivity. Understanding dynamic typing and duck typing is crucial for Python programmers because they shape the way variables are handled, how functions operate, and how polymorphism is achieved in Pythonic code. Dynamic typing means that the type of a variable is determined at runtime rather than at compile time. In statically typed languages like Java or C++, the data type of a variable must be declared explicitly and remains fixed. For instance, declaring a variable as an int or string in Java restricts it to that type. In contrast, Python allows a variable to point to an object of any type, and that association can change at any time. For example, a variable that initially holds an integer can later be reassigned to a string, a list, or even a user-defined object. This behavior is possible because variables in Python are essentially labels or references to objects in memory, not containers that store values of a specific type. The main advantage of dynamic typing is its convenience and speed in development. Developers can write functions and data structures without rigid type constraints, enabling greater generality and less boilerplate code. However, this flexibility can also lead to runtime errors if variables are used in incompatible ways. For instance, trying to perform arithmetic on a variable that was expected to be a number but is actually a string will raise a type error. To mitigate such risks, many Python developers use unit tests, runtime assertions, or optional type annotations introduced in Python 3 to provide hints to human readers and static analysis tools. Duck typing is closely related to dynamic typing and takes Python's flexibility a step further. It refers to the practice of not checking an object's type explicitly, but instead relying on the presence of certain methods or behaviors. The term originates from the saying, if it walks like a duck and quacks like a duck, it's probably a duck. In Python, this means that the specific class of an object is less important than whether it implements the methods or operations being used. For example, if a function expects an object with a .read method, it doesn't matter whether the object is a file, a socket, or a custom class. As long as it has a .read method, it will work. Duck typing is a form of polymorphism that encourages writing generic and reusable code. It avoids the need for cumbersome type hierarchies and promotes composition over inheritance. At the same time, it requires careful documentation and testing because the responsibility for ensuring correctness lies more heavily on the developer than in statically typed environments. In summary, Python's dynamic typing allows variables to be bound to objects of any type at runtime, facilitating flexibility and rapid development. Duck typing complements this by focusing on an object's capabilities rather than its formal type, enabling polymorphic behavior and reducing the need for rigid interfaces. Together, these features are emblematic of Python's philosophy of simplicity and power, but they also require disciplined programming practices to maintain code clarity and correctness.